Let's see. Hi, everyone. Thank you for coming. Who is me, or who is I am? I'm Péter Ábel Nagy. I'm a lead software engineer at EPAM Switzerland, and I'm going to talk about blockchain today. But before we start that, obviously, you can ask your questions in the slide view. Yeah, if you haven't figured it out yet, I think it's not the time. But before you ask any questions, I have a couple of questions from you. Who of you have cryptocurrency? Who owns cryptocurrency? Okay, cool. A lot of people. Who made money trading or owning cryptocurrency? Okay, very good. This is a little bit more uncomfortable question, but who lost money trading crypto? All right, a couple of people. Sorry for your loss. It was me, like a couple of years ago, in 2018, when I first purchased Bitcoin. So, why did I ask these questions? Because we are going to talk about how to make that sweet Lambo money that everyone wants, only not trading crypto, but the slow way, by developing blockchain. So we are going to talk about how to get into blockchain development and how to utilize this technology in your day-to-day life. Why should we talk about this? As you can see in the slide, during the last year, the open positions for blockchain basically grew exponentially, 500%. And that is why we are talking about this whole thing still. Nominally, it's not that much. Obviously, we don't have millions of blockchain engineers on the block, but still, you can observe a trend here. And I will also pay attention to the second line, which is security engineering, because blockchain and security are really closely related together, and I'm going to talk about it a lot. But how can you utilize this new technology that is on the block, and which are the areas that you should really concentrate on? As you can see, I managed to gather 8 distinctive points. Some of these points are there because of symmetry, like supply chain. Others, like banking, obviously it's very important. Cryptocurrencies there, smart contracts are there. As they call it, this is a disruptive technology in the banking sphere. All-time bankers hate it. But if you ask Michael Saylor, he loves this. But I'm not going to touch on this so much. We can talk about healthcare. How would you utilize this technology in healthcare? Obviously, you have a lot of patients' data, and this data should be protected. Meaning, you cannot just send or transfer data because it is privileged data. That's one of the biggest problems in healthcare, that you have several different private healthcare providers, and you have a track record at one place. For instance, I was living in Hungary. I grew up in Hungary. I moved to Switzerland. All of my healthcare data is still in the Hungarian system. I cannot really transfer anything automatically, at least not. Blockchain can be a solution for that problem. If you have a system which is built on blockchain, your data is secured, it is encrypted, and basically you can share privileged data across the board. You can transfer it via healthcare providers, because you, the patient, is the owner of the actual data, and if you have the private key to the encryption, then no one really can see it. In the case of real estate and IoT, real estate, one of the most popular crimes nowadays, that people taking on loans on someone else's property, basically, which is terrible. So it's a form of identity theft and also actual theft as well. And in this case, if you have an open ledger, which is basically a blockchain, you can really track all the transactions that are on a property, and also you can protect your identity. In the case of IoT, it's a different story. You have all of these systems connected to the internet, all of these tools, okay? Personally, I don't like it. I don't need my fridge to tell me what's the weather like, because it's next to the window, so I just look out and I can see whether it's raining or not. But if you think about it, you still need secure communication, and we can utilize blockchain almost like a database in this case, because you can track the interaction of a customer or a user with a device. You can put it on the blockchain like a transaction, and then you have this log or database of all of the interactions. Then you can later analyze your customers' behavior on these devices and improve on them. So IoT can hugely benefit from this technology. Supply chain, tracking things, tracking, for instance, pharmaceuticals can be this way. Government, we had a lot of talk about putting our voting system on the blockchain and use this technology. It's a very far-fetched idea, given that the age group and the voting base mostly consists of older people, and we don't even have a decent electronic voting system yet. So I think we can forget about that. Cybersecurity, I'm going to talk about it later. Social media is the whole Web3 concept. You are the owner of your own data, not Facebook. So, okay, it's very cool that Facebook can tell you or can predict when you're going to poop, but I would say it would be better if they couldn't. AI is the same thing as I mentioned in IoT. Basically, in the case of blockchain, you have a log of all of these transactions. All of the transactions, it's immutable, you cannot change it. Therefore, it acts as a database, of some kind of database. But as you may see, I would put everything on a blockchain. I'm like a hammer, and for me, everything is a nail. I would put even my grandmother on a blockchain and distribute it and decentralize it, but yeah, that sounded terrible, sorry. So actually, this is just a tool that we can utilize in many different places. The question is, should we utilize it in different places? We'll find out. But before we do that, how would you get into this whole space? I started out as a Java engineer, still a Java engineer. And recently, I'm getting a lot of questions from colleagues, from all across my company, EPAM, and also from other places. Okay, I really want to work in this technology. How would I start? What should I look out for? Basically, you have two options. Become a core blockchain engineer, or become a so-called blockchain software engineer or software developer. The former, if you become a core blockchain engineer, as you can see, I gathered a couple of points. What is this job consist of? And most of these points consist of the word design. Meaning you are doing the work of an architect actually. So a core blockchain developer is someone who designs the protocol, designs the network, and the security, and everything else. It is something that is harder to get into, and because it requires like another set of knowledge that most of us engineers or developers has, but still it can be done. You just have to get some networking knowledge, read a couple of white papers. For instance, Satoshi Nakamoto's Bitcoin white paper is a good starting point, and just get into it. And the same goes for blockchain software developer. It's kind of a different animal, because if you are a developer and somehow you are utilizing this blockchain technology, you can call yourself a blockchain engineer or a blockchain developer. And as it stands now, it's basically just a marketing phase, a catchphrase for recruiters. But still working. So you can have like a most basic front-end or back-end developer job, but if your project utilizes blockchain somehow, you can state that you are a blockchain software developer. Basically, I would say just go to LinkedIn, do some courses, and basically lie on your resume if you want to get a first job. This is how I get my job here, talking to you right now. So it works, and I can tell you it's much less uncomfortable to start as a developer in a job after you line your resume than standing in front of a bunch of people. And you can get into it really fast. And this is basically the track how to get into it. Understand the fundamentals, just go read the white paper. It's not that complicated, and I'm gonna make it even easier for you because we're gonna go through the basics. Start coding. You probably are engineers, so you know that one. Learn smart contracts. That's different kind of things. You really have to get into like this whole banking mindset if you want to understand that. Read blockchain-related content. Everything you can get into it, and just keep improving. So nothing major. So what is the blockchain? Because I mentioned a lot of different definitions right now, like ledger, blockchain, things like that. It's not magic, I can tell you that. So Shia LaBeouf, you can leave us alone. This is a blockchain, or this is a visual representation of a blockchain. I would put into two parts. We have the blocks, which is just a virtual object, and somehow they are chained together. So the block in the blockchain has two very important attributes: the previous hash and the hash itself. And the data that you can see there is basically can be anything. That can be the JPEG that you can sell for thousands of dollars. That can be the song that you want to protect. Also, that can be the data of the transactions that is so valuable as well. But the tricky part is in the hash and in the previous hash. So in the case of a Genesis block, we don't have a previous block because that's block 0 or block 1. It depends on how you look at it. But if you look at the block 2, you can see the previous hash is pointing to the hash of the previous block. And this is how we get the chain part. Each block points to the previous block. Therefore, they cannot be shuffled around, cannot be taken out of this context. That's how we get the chain of blocks, basically. The hash itself is something that we call the proof of work in some cases. I really like to show you that this is just a very simple object, basically. In a Pojo, this is how it looks like. You have this very simple class with a couple of variables in it. And the most important part is the previous hash and the hash. We have a couple of things here like time step and nonce. I'm going to mention them later. But it is really easy to understand. It's simple as a brick, so to speak. How does it... But how we chain together these blocks. So we have the hash calculation. The hash calculation done by a SAJ 256, very standard hashing algorithm. It is really cool because it gives a lot of security to the system. So for you to be able to break this hashing algorithm, you would have to go through to the power of 256 variations of a certain hash, that is virtually impossible. Therefore, you have a very secure, encrypted thing here. But you can see that calculating the hash is not all of the process. We also have to so-called mine the block. This is the process where we create a new block and publish it to the network itself. And this is the interesting part, because what we did here in the case of a proof of work concept, we are increasing the difficulty of finding this hash with this nonce. Nonce is a number used only once. And in this case, what we are doing, we are placing zeros in front of the hash. So when you're calculating the new hash, you're not just calculating a new hash, you want to find the hash that starts with a given number of zeros. This is how we increase or adjust difficulty. And it's very important because the whole concept is you can have this chain of blocks, but it's not going to be secure because you can really just switch up the whole thing. But we introduce computational complexity into the system, and meaning you will have to spend a lot of resources on mining a block. So for you to change the ledger, change the previous blocks, you will have to recalculate each hash of each block, which will be increasingly difficult. And in the case of Bitcoin, it's meaning it's destroying the environment, or kind of destroying the environment. I don't really agree with this premise, because the traditional banking system, I think, uses a lot more energy than the Bitcoin network does. But still, we have this problem that the proof of work concept is very secure, because you have to have enormous amount of resources to overtake the system, but it's very costly as well. So let's talk about the other option that we have, which is a proof of stake. And the proof of stake will be increasingly important in our use cases later, because proof of work, even though secure, you cannot really utilize it in a way that probably we would want to. So the proof of work system works quite differently than the proof of stake. We don't have this problem that we have to solve, but we have, so to speak, stakeholders. The stakeholders are just nodes that has some kind of stake in the system. In the case, for instance, the Ethereum network, meaning you are staking your own Ethereums. Therefore, we can be fairly sure you wouldn't want to compromise the whole network, the whole blockchain itself. And basically, if you stake enough coins, you have the right to validate the newer blocks. This is how it looks like. It's very similar to the proof of work POJO. The only difference we have another variable, which is the validator. And this is how we calculate the hash. Very similar. The same thing. We want to have the previous block's hash in our hash, and also we want to have we need to point to the previous block as well. And the validation will be quite different, because we are not solving for a problem. We are actually just doing a simple task, and the whole essence of this process is how we choose the validators. All right. How does it come to cybersecurity? Because I mentioned previously, this is the most important part. Cybersecurity costs $445 billion each year, and that's a number that really makes me think that I should have become a black hat hacker, but I didn't. And also, we have a lot of opportunity to basically get rid of and so to speak, fight off these relentless attacks that cost the global economy in this enormous number each year. Now let's talk about the CIA, the three main principles of cybersecurity. We have confidentiality, meaning that, okay, how does it come to blockchain and how does it come to crypto? I think there is a lot of things that crypto solves us. Confidentiality. We have the encryption in the blockchain. We have the encrypted messages. And I would say that even though everything can be hacked, as I mentioned, within reason, it probably can't. So you're not gonna have, you're not gonna go through 2 to the power of 256 variations just to hack into a hash. That's, as I mentioned, not gonna happen. And in this way, because everything is hashed in the blockchain, we have this kind of security, we have this kind of encryption. We have integrity. Integrity meaning blockchain is immutable. You cannot go back and change up the blocks. You have a very transparent but rigid, some kind of a system, and that's how you ensure that no one gonna ever go back and change anything that has happened. So if you have a transaction, you can be fairly sure that someone actually did that transaction, and even it hasn't, even somehow security was compromised, you can go back and track it. We had the heartbeat bug in the case of SSL. One of the biggest problem was you didn't know that your system is compromised or not. Okay, so each transaction that happened looked like a standard transaction, and therefore everyone was going crazy when we find out about it. You had to go back and go to the CA authority and get a new key for encryption. So integrity is a very crucial point in this case, and not just integrity but trackability. Availability is basically refers to the openness of the blockchain. So it's a public ledger. If you participating in a public ledger as a node, you can see the whole history of the network and the chain, and every data is available for you. This, here I like to mention what kind of ledger types we have. Yesterday, there was a very interesting talk about Project Persia from GFrog. And one of the questions was, how would they ensure that nodes actually would participate in their system? Because they don't have a reward like Bitcoin and Ethereum network does. So one of the possible solutions could have been, in their case, if they go with a public ledger, they just build upon, for instance, Ethereum or Bitcoin. Which is, the problem is, it's open, it's there, the reward is there, and you can be fairly sure that Bitcoin is not gonna go to zero. And like, yeah, it went up like 1% last day, so like, suck it, bears. We're gonna win eventually. But still you have this kind of risk. If the whole network or the reward would be worthless, the network would go to zero, then your application gonna go to zero as well. And also it's very costly. But you have another choice. You can go with a private ledger. Private ledger is a very interesting thing because basically you restrict access to your network. Not everyone can become a node and can participate in this system, but you can really ensure that this system gonna persist. So one scenario could be you are a bank, you have operators, and the client side you wanna do some distributed authentication network or system. So instead of going with Spring Security OAuth2, where you have a centralized store for your JOT token, you want to go with the decentralized way. You can really run your nodes as your client. So the operator's computer become a node. Therefore, every data will be decentralized. So if they hack into your system, they can compromise one or a couple of nodes, but still the whole system can can be operational still, and what you can do with it, basically the whole blockchain will point out all the security problems, also fix the problem in itself. And in the case of a private network, you would want to go with the proof of stake concept. So you're not gonna, you don't wanna burn a lot of energy. You don't want to sacrifice computational power, but you still want to have this decentralized system, and that can be a good solution if you're doing something like authentication in a closed environment. Consortium is a very similar solution to a private network. The only difference is you have several different participants in this network. So in a case, let's stick with the bank. You have a bank, you have hedge funds you are working with, you have the government you are working with, you have post office, maybe, things like that. And what you want to have is a introducing trust via this blockchain. So you have a blockchain solution, you have a transaction list, for instance, and even though you have all of these contracts, still legal contracts, you can really introduce trust into the system and say, hey, government, these are all the transactions that we did with the hedge fund. So you can really trust us because there is no way for us to go back and modify any data or even push not valid data because everyone has a right in the system. So consortium can be a good solution, cases like that. As I mentioned, as I said previously, one of the coolest things that I've seen, and there's a couple of projects that are working on it, making the central authority obsolete. So what they do, you still have the same SSL, but instead of a central authority, you're gonna go with the distributed and decentralized network, and each node would validate whether this website is valid or not. Okay, I don't know whether it's a good idea or bad. I just don't like the word authority. Like maybe it's like late teenage angst, but still, I I think it's a very cool solution, and it would have prevented the heartbeat bug, for instance, in this case. Okay, how to integrate blockchain with your Java backend? You have a couple of different solutions. You can code everything basically from scratch, and it might not be a bad idea, especially if you are going with a private network. Then why not? You can really put everything on the block that you want. It's very easy to code, and everything else is just networking. But if you don't want to go that way, you have Web3j, which is a very lightweight Java library. You can integrate with any kind of blockchain with it. Not a bad solution. OpenLiberty is a project from IBM. It is focused on authentication and authorization and security. The upside is that it's very good and done by IBM. The downside is you have to work with IBM, which is costly. And also you are losing on the whole public, basically the benefit of a public library. So there is that. BitcoinJ is a library for Bitcoin. If you want to put your application on the Bitcoin, the only downside is it's very costly, and you have the risk of a public network. If the price of Bitcoin will go to zero, the network gonna go to zero, then your application goes with it. OneCosmos is very similar to OpenLiberty. The only difference is it's not IBM, it's much cheaper, but it's a smaller company, so the risks that are involved are there. Okay, what kind of programming languages you should know? You can do it with any programming languages. You can use blockchain with any programming languages. C++ is a given because it's very fast. Solidity, this is the programming language. If you want to integrate with Ethereum, you have to learn Solidity. It's very easy. You can find a lot of examples in the internet, so probably very easy and fast to learn. Python, the case for Python is the same as every other time, very easy to program. Rust is very, very popular nowadays. A lot of blockchain uses it, a lot of Ledger, Polkadot, Aaron. Rust is a way to go if you want to jump in and you want to switch from Java, for instance. I would learn Rust, but you can do blockchain with everything, as I mentioned. You can implement it yourself or integrate it even if you are using Java. How EPAM can help with you. So we have blockchain department since 2016. We have 30+ projects all across the world. We already developed and shipped a couple of things, and we have a growing community of blockchain community. So if you're interested in this topic, go look for the guys outside, check out the opportunities within the company. We have a lot going on right now and really focusing on this thing. So if you're interested, look us up. Maybe we can find something for you. So with that, I'd like to thank you for your attention, and let's see the questions. Give me a sec. Cool. Okay, could blockchain technology prevent people lying on their resumes? Maybe, why not? If you would develop an application and integrate with companies, then yeah, probably. I can think about it. As I mentioned, I am a hammer, so everything is a nail for me. Okay, you spoke about healthcare. Couldn't I do exactly the same with DB and encrypted data? How? Yes, but it's harder to migrate data from database to database if you have experienced that. In the blockchain, and also not, because the point is the private key is at the patient. So the ownership of the data relies on the patient. It's just easier to transfer the data, And also, for instance, if you go, like in my case, I went from Hungary to Switzerland. In Switzerland, it would be easier just to transfer the data via blockchain, like a centralized application, and then just give my doctor the access to my data, for instance. So you are the owner of your data. That's the whole point. Do you think traditional banking systems using more energy than Bitcoin does? I mean, is it true per transaction as well? No, not in the case of transaction, but if you're working banking, we have the offices. We have a lot of employees. They are commuting every day. They are wasting time in the office as well. So obviously, it would mean that we should get rid of a lot of jobs as well. But I don't have numbers. I have a gut feel in this regard. But yeah, I would say traditional banking systems still cost a lot more just because the whole infrastructure. How are currently cryptos preparing to be quantum resistant? Okay, so it goes back to encryption. You have to increase. So if you have quantum computers, they can, for instance, brute force this 2 on the power of 256 options very fast, meaning you just have to adjust the encryption protocol, basically. So if you have better computers, you're gonna come up with better encryption. It's not gonna be a problem. When BTC, we'll get back to so BTC was 69, nice, okay, and not just 60. And I don't know. Like I'm in this space since 2017, so I spent a couple of years losing money. I'm losing money again, but I am up overall, let's say. Open Liberty is a microservice framework. Oh, and anything that you've heard is not financial advice, because I'm barely capable of making good financial decisions myself, so don't listen to me. Open Liberty is a microservice framework. I don't see how this is connected to blockchain. They have a blockchain project. So this is what they said on the website. I don't know. Okay, next question, please. Can you share one project which uses blockchain and the projects actually used? Makes sense there. So I think there is, for instance, this project Persia makes a lot of sense to me. And it's a really cool decentralized packaging system. Also, I myself working on a project that want to use decentralized authentication and authorization. And it comes back to security, like how hard do you want to make the hackers to get to your data? If it's decentralized, it's obviously harder. Okay. And I cannot really share it yet, so that's my answer. Wasn't everything on blockchain thing in 2017? Is there some company using in? Yeah, increasing number, as I mentioned. Like there is a 500% rise or increase in open positions. So a lot of company using blockchain nowadays. Okay, that's it. That's it, I guess. Okay, thank you very much again. Thank you for your attention, and have a nice rest of the day.